It's always such an honor to spend time with you and to be together with you. You hit the play button and you made the time to listen. I know that you value your time and you have made the time to listen today. You have limitless abilities to have the capacity to learn new things, to make your learning process little better. Through your attitude, action, and response, you can definitely move forward in your learning journey. And today's topic is on particular integral of f d of y is equal to e power ax. And this topic is from linear differential equations of higher order. And these are the four problems which are very, very important. And I'm going to explain you the working rule first. So the working rule for f d of y is equal to e power ax. The first thing is for particular integral, so we have to write as 1 by f of d into e power ax. So in place of d, we have to substitute a here. So put d is equal to a. So if you get a value, leave it as it is. If this is going to become 0, then again, so we have to keep one x in the numerator and we have to go to the previous step here. So here in the previous step, so we have to make a derivative for this. So we have to keep one x in the numerator. So f of d is equal to f dash of d into e power ax. And again we have to substitute d value is equal to a. So if you get a value here after keeping d is equal to a, leave it as it is. If it's going to become 0, then see here. So again we have to keep one x in the numerator. So we have to go to the previous step here. So in the previous step, so we have to keep one more x here in the numerator and we have to make a derivative for this denominator. This will be f double dash of d. And again we have to substitute d is equal to a. So if you get a value here, leave it as it is, or else you continue the process like this. So this is the working rule, and therefore we have to find the solution for the first question, that is d cube minus 5d square plus 8d minus 4 of y is equal to e power 2x. So in order to find the particular integral, just I'm giving the general solution here. So in the solution, the auxiliary equation here is, as you know, that is f of m is equal to 0. So here in place of d, substitute m here. This will be m cube minus 5m square plus 8m minus 4 is equal to 0. Using the synthetic division method, so I'm going to find the roots for m here. So the quotient of m cube is 1. This is minus 5. This is 8. And this is minus 4. See, the first thing I'm going to check with 1 here. So keep 1 0 here. So this is 1. So 1 into 1 is 1. So minus 5 plus 1 is minus 4. And again we have to multiply these two. This is minus 4. 8 minus 4 is 4. Again we have to multiply. 1 into 4 is 4. And this value is 0 here. And the next value here is, so again we have to check. So I'm checking with 2 here. 0 we have to keep 1. 2 ones are 2 here. This is minus 4 plus 2 is minus 2. And again if I multiply, this will be minus 4. The value here is 0. So here are the factors. So this is 1 and 2. So 1 is m minus 1 we have to write. And here m minus 2. And this is constant. And this is the quotient of m. This is m minus 2 is equal to 0. And therefore we got the values as m is equal to 1. Here m is equal to plus 2 and this is plus 2. So if you observe properly, so we have an equal root here. So the yc can be written as yc is equal to, for this we have to take a single constant c1 e power x. So for this 2, so we have to take a combination c2 plus a c3x into e power 2x. Clear? And therefore we have to find the particular integral now. So for finding the particular integral, as usual, that is yp is equal to 1 by f of d. So what is f of d here? F of d is nothing but, see here, this is d cube minus 5d square plus 8d minus 4 into e power 2x. Into this value is e power 2x here. So in place of d, substitute 2. First thing is we have to replace d by 2. So here yp is equal to, so yp is equal to, this is 1 by, in place of d I am keeping 2 here, minus 5 into 2 square plus 8 into 2 minus, this value is minus 4 into e power 2x. So here yp value is going to become, this is 8 minus 4 5s are 20 plus this value is 16 minus 4 into e power 2x. So if you observe this one, so this value is 24 minus 24. So here 24 minus 24 into e power 2x. Now we are going to get cancelled here. So we have to go to the previous step here. So here after substitution, so this is the previous step here. The previous step is this one. So we have to make a derivative. We have to keep one x in the numerator and we have to make a derivative for this. So this will be 3d square and this is 2 5s are 10 minus 10d plus for d it is 1 here, so keep 8 here. For constant this is value is 0 into e power, this value is e power 2x. And again we need to substitute the same process here, d is equal to 2. So if I keep d is equal to 2, then see what happens here. This value is going to become 3 into this value is 2 square minus 10 into 2 plus 8 into e power 2x. So yp value is equal to 1 by, see here, this is 4, 2 square, this is 4, 3 is 12 minus this value is 20 plus 8 into e power 2x. So yp value is equal to, so this value is 20 minus 20 into e power 2x. So again the denominator got cancelled and therefore see here we have to go to the previous step here. So what is the after substitution? Before substitution, the previous step here is this one. So we have to keep one more x in the numerator and we have to make a derivative. So see here, now for this step I have to keep one more x here in the numerator. So it is going to become x square and we have to make a derivative. So 2 if it comes front, so this will be 6d minus for d it is 110, for constant this is 0, e power 2x. So here in this, so we have to put d value is equal to 2. So if I keep d is equal to 2, then this is going to become x square plus 6 in place of d2 into 10 into e power 2x. So yp value is equal to, this value is nothing but x square. So this is nothing but 12 minus 10 into this value is e power 2x. So yp value is equal to x square by 2 into e power 2x. And this is our yp value. Yp value is equal to x square by 2 into e power 2x. Clear? And therefore our general solution is y is equal to, this is yc plus yp. So what is yc here? So yc is very clear here as 1 2 2, that is c1 e power x plus c2. So this is a c1 e power x and we have an equal root, that is c2 plus c3x into e power 2x plus the particular integral yp is x square by 2 into e power, this value is 2x. And this is the general solution. See here, so we have to find the roots first of all, and after finding this will be the complementary factor, and next one particular integral is this. So we have to keep d is equal to 2 here. After substitution, if the denominator is 0, so we have to put one x in the numerator and we have to go to the previous step here and we have to make a derivative for this. So after making a derivative, again we have to keep d is equal to 2 and see here this value is 0 and therefore we have to go to the previous step here. So this is the previous step here. So we have to take one more x in the numerator and we have to make a derivative for the denominator. And again we have to keep d equal to 2 here. And so we got a value, leave it as it is. And this will be the particular integral. And therefore this is a general solution, that is complementary factor plus particular integral. And the next question here is, find the particular integral of, so this value is d cube minus 6d square plus 11d minus 6 of y is equal to e power minus 2x plus e power minus 3x. So as usual, the auxiliary equation here is, so the auxiliary equation is f of m is equal to 0. So in place of d, we have to keep m is equal to 0 and therefore this is going to become m cube. So this is going to become m cube minus 6m square plus 11m minus 6 is equal to 0. The quotient of m cube is 1 here. So here we have to make a synthetic division here. The quotient of m cube is 1. This is minus 6, 11. This is minus 6. So here we have to check with 1. So this is, we have to keep 1 0 1 1 ones are 1. This is value is minus 5. 1 into minus 5 is minus 5. So we got plus 6. So this value is plus 6. And the next one we am going to check with 2 here. So this is 0 1. 2 ones are 2. This is minus 3. And this value is minus 0. So here the factors are m minus 1. Here it is m minus 2, and this is constant and this is quotient of m. So this can be written as m minus 3 is equal to 0. So we got the roots as 1 comma 2 comma 3, and therefore yc value is equal to c1 e power x, c2 e power 2x, and c3 e power 3x. And therefore the complementary factor we got is yc is equal to c1 e power x, c2 e power 2x, c3 e power 3x, and therefore we have to find the particular integral. For finding the particular integral, so yp value is equal to, this is 1 by, so here what is f of d here? D cube. So this value is d cube minus 6d square plus 11d minus 6 into e power minus 2x plus e power. So this value is e power minus 2x plus e power minus 3x. So we have to separate. So here, how to separate this one? This is 1 by d cube minus 6d square plus 11d minus 6 into e power minus 2x plus 1 by, this value is d cube minus 6d square plus 11d minus 6 into e power, this is minus 3x. So in place of d we have to keep, so in place of d I have to keep minus 2 here, and in place of d I have to keep plus 3 here. So here simply we have to substitute minus 2 in place of d here. So this is going to become, this is minus 2 whole cube minus 6 into minus 2 whole square plus 11 into minus 2 minus 6 into e power minus 2x plus, so in place of d we have to keep minus 3 here. So this is minus 3 whole cube minus 6 into minus 3 whole square plus 11 into minus 3, this is minus 6 into e power minus 3x. Clear? And therefore yp value is going to become, so this value is minus 8, so this is minus 8, this is plus 4, this value is 4 6 are 24, this is minus 22 minus 6 into e power minus 2x plus, so minus 3 whole cube is nothing but minus 27 9, so this is 9 into 6, 9 9 6 54, and this is minus 33 minus 6 into e power, this value is minus 3x. So this is minus 27 minus 54 minus 33 minus 6, and see here, so this value is clearly, this is minus 1 by 60 e power minus 2x plus, this value is minus 120 e power minus 3x. So if I take LCM as 120, so if I take LCM as minus 120, this is going to become 2 into e power minus 2x plus this is e power minus 3x, and this is our yp here, and therefore the general solution here y is equal to yc plus yp. What is our yc here? This is yc, that is 1 2 3 are the factors, and therefore this is c1 e power x plus c2 e power 2x plus c3 e power 3x minus 120 into, this is 2 into e power 2x plus e power minus 3x, as this is yp. So this value is yc. So if you add, so we'll be getting the solution for equation 2. And the next one here is the third question. So we have to find the particular integral. So this is d square minus 3d plus 2 of y is equal to cos hx. So the auxiliary equation, the first thing is, in order to find the complementary factors, so auxiliary equation is f of m is equal to 0. So in place of d I'm going to substitute m here, then this is going to become m square minus 3m plus 2 is equal to 0. So here are the factors, minus 2m minus m plus 2 is equal to 0. So if I take m common, this will be m minus 2. If I take minus common, this value is m minus 2 is equal to 0. If I take m minus 2 common, this will be m minus 1, 0. So m values are 1 comma 2. So here are the two roots here. So yc value is equal to, so yc is equal to c1 e power x plus c2 e power, this value is 2x. And next thing here is we have to find the particular integral. For finding the particular integral, yp is equal to 1 by, so here f of d is nothing but this value is d square minus 3d plus 2 into cos hx. So cos hx can be written as, so this value is 1 by, so this value is d square minus 3d plus 2 into cos hx can be written as e power x plus e power minus x by 2. So we have to convert this in terms of an exponential notation. So here this is going to become, as this is a half here, half times of, this is d square minus 3d plus 2 into e power x plus this value is a d square minus 3d plus 2 into e power minus x. So in place of d we have to substitute plus 1 here, and in place of d we have to keep minus 1 here. So here if I substitute 1 in the first term here, that is 1 minus 3 plus 2 into e power x. Here if I substitute minus 1, this will be plus 1. If I substitute d is equal to minus 1, this is plus 3 plus 2 into e power, this value is minus x. So yp value is equal to 1 by 2 times of, this is plus 3 and this is minus 3. So we have to keep 1x in the numerator and we have to go to the previous step and we have to make a derivative. For d square the value here is 2d and d it is 1, and for constant this is 0 into e power x, and this value we got a value, leave it as it is, that is 5 plus 1, the value here is 6 into e power x. So here again we have to keep d value is equal to 1, the same process here. So if I keep d is equal to 1, yp value is half times of x into, this is 2 minus 3 into e power x plus 1 by 6 into e power minus x. So this value is nothing but half times of, this is minus x, this value is minus 1 into e power x plus 1 by 6 into e power minus x. So 1 by 6 into e power minus x, and this is our yc value. So yp value is equal to, this value is half times of minus x into e power x plus 1 by 6 into e power minus x, and therefore the general solution y is equal to, see here, y is equal to yc plus yp. So what is yc here? Yc is nothing but, we have two roots here, 1 and 2, and therefore so yc is equal to c1 into e power x and c2 e power 2x, and this is our yp, that is half times of minus x into e power x plus 1 by 6 into e power minus x. And the last question here is, so we have to find the particular integral for d square plus 5d plus 6 of y is equal to 0. So every time we have to go with an auxiliary equation. The auxiliary equation of 1 is, the auxiliary equation is f of m is equal to 0. So here we have to keep in place of d as m here. So this is m square plus this value is 5m plus 6 is equal to 0. For 6 the factors are 2 and 3, that is m square plus 2m plus 3m plus the 6 value is equal to c. So if I take m common, this will be m plus 2. If I take 3 common here, this will be m plus 2 here. So if I take m plus 2 common from this equation, so this will be m plus 3 is equal to 0. So m is equal to minus 2 minus 3 here. So yc value is equal to c1 e power minus 2x and c2 e power minus 3x. And therefore yc value is equal to, the complementary factor here is c1 e power minus 2x and c2 e power, this is minus 3x. And here with the particular integral, for particular integral 1 by f of d. So what is f of d here? D square plus 5d plus 6. So d square plus 5d plus 6 into, this value is e power x. So we have to substitute the quotient of x here, that is d is equal to 1 here. So we have to keep d is equal to 1 in this equation. So here yp value is equal to, so in place of d if I keep 1 here, this will be 1 square plus 5 into 1 plus 6 into e power x. So yp value is equal to, this is 1 plus 5 plus 6 into e power x. So yp value is equal to 1 by, this is 6, 12 into e power x. So we got the yp as So yp value is clear as, so here yp is equal to 1 by 12 into e power x, and therefore the general solution here y is equal to, the value here is yc plus yp. So what is our yc here? So yc value is nothing but e power minus 2x plus e power c1 e power minus 2x plus c2 e power minus 3x plus 1 by 12 times of e power x. And this is our general solution here. This is how we have to solve each and every problem. So in each and every problem, the working rule is vividly explained, and it is implemented in each and every question here. So if you follow the working rule and if you follow all these 4 problems, definitely you can solve any problem of this kind. So I have given solutions for each and every important problem from the textbook. So the solution is given and video is taken and it is uploaded. Check the playlist and your preparation will be damn easy. Thank you so much for watching. If you really like, you know what to do, please subscribe and pass it on to as many friends as you can. That is the greatest help needed. Thank you so much.